In this video, we're going to be going over collisions with hash tables. So I want to bring us back to hash maps. So remember, a hash map is a implementation of a map that is done with a hash table. And we talked about it already early on when we talked about all the abstractions. So if you haven't kind of made that connection yet, hash map is a map with a hash table. Hash set is a set with a hash table. So a regular map and a regular set are going to use trees, and a hash map and hash set will use a hash table. So oftentimes when we're talking about these collisions, we're thinking about maps because those are often the abstractions we use to do quick lookup, right? So if there's no collisions, search, insert, and remove are all constant in terms of their complexity. With a hash table, all you have to do is compute the index from the key, which is just passing it through a hash function, which is always going to run the same amount of operations no matter how many different elements are inside of your array. So there's two factors to consider with a hash table. One factor is if the hash table is way too small, so worst case would be like an array that has only one element in it, then every time you hash, you're going to go to the same element, and then you're basically going to get the same complexity as an array or a linked list, which will make more sense after we talk about the collisions in the next couple of videos. Similarly, if your hash function isn't any good and it doesn't spread out the keys after they're hashed, for example, this is a really bad hash function that always returns 4. In that case as well, you're basically putting everything into the same spot. And so in those cases, the worst case complexity is going to be ON. It's just going to converge to the complexity of a linked list or an array. So one thing that's interesting to think about is the birthday problem. I don't know if you've ever heard of this when you took your probability class, but the problem is basically if you have a group of n people, what are the odds that 2 people have the same birthday? So it depends on the value of n, and you can see the distribution here in this plot. So basically, if your n is less than 23, it's not as likely, you're more than likely not going to have 2 people with the same birthday. But if your n is greater than or equal to 57, so that goes like right here, in that case, your chance of 2 people having the same birthday is above 99% possible, or 99% chance. So this is to say that it's more than likely that, with hashing, that you're going to have collisions. So writing perfect hash functions is particularly for hash functions that need to work generally, not for a particular problem or a particular type of key. You're going to have collisions and you're going to need to deal with them. So again, a collision occurs when you have a hash function that returns the same index for 2 different keys. So let's say that we hash the key number 1 using our hash function, and we want to place 123 in that element in the array. So we hash, it gives us a location in the array, and then we put 123 there. But then we hash key 2, and let's say that that hash returned the same location that the one above it did, key 1. Then we basically have a collision. We're trying to place 2 things with 2 different values in the same location in the array. Sorry. So how do we handle collisions? Well, we have a couple of options. One is to just keep working on the hash function so that you don't have any collisions, and that is possible. And you can always customize your hash functions to work really well for very specific problems. You could not use hashing, go back to trees. Or there's 2 collision handling strategies that we're going to go over in the next 2 videos. So the first one is called chaining. Chaining is basically just creating a linked list off of the node that has two keys mapping to the same location. And then the second option is something called probing. Probing is basically once you've reached a collision, or like once you have a duplicate index that's produced, you basically just like walk through the array until you find a free one. So those are your two options. So what are the trade-offs? So both of them require you to linearly search on collision. So one allows you to linearly search along this linked list, and so the complexity is going to depend on how many collisions there are in a particular node. So it's not bad if you can keep collisions small, the total number of collisions at any one index small. Worst case for the chaining would be that everything hashes to the same index, and so then you just have a linked list and all of the elements are in the linked list, which would mean that you have just turned your hash table into a linked list. Probing is the same. It's harder to think about, but probing is, and we're going to talk about both of these in great detail, but probing is that you take, you hash, you go to an index, and then you just walk through the array until you find a free spot. So again, in the case where every single element hashes to the same index, then you're just going to have to walk through the array basically in order to find what you're looking for, or to place whatever you're inserting into the right spot. So that kind of converges to what an array would do. So you're turning your hash table into an array. Some other trade-offs, probing works with your existing hash table setup, so you don't have to change anything. It's just that array. Where, I hope I just said probing. Probing works with your existing hash table setup. Nothing has to be changed. It's just how you insert and how you search is slightly modified. Chaining, on the other hand, requires like a different setup to your hash table. Because now you have a linked list, so you need to think about what you're actually going to store in the array. It won't be the values anymore. You'll need to store pointers or something like that instead. So in the next couple of videos, we're going to go through what chaining and probing looks like with some real code and actually handling these collisions with those two different strategies.